All right, I think we should get started. And since I'm running the show, we will get started. There we go. So the session this morning came out of discussions we've had in the last two hard hats, but last year there was, in the air, there was a discussion about training. I have an interest in, I teach a class at the School of Information, University of Texas, on scientific and technical data, which I discovered, because I wasn't surprised, but there really is no established codified body of knowledge here, which sometimes puts the students off. I'm like, we're going to find out. So part of the reason that John Chin and I tried to pull this together was, I think it's time for us to try and map out what that would be. As I said yesterday, since data seems to be in the New York Times every other paragraph, if not every other day, and big data is all over the business world, and we're scientists, so data are us. I think it's time that we can actually do that, and the people on the panel here have actually been engaged in teaching these things for a lot longer than I have, and working in these areas, and so I'm looking forward to us trying to start the conversation of how would we develop the somewhat codified emerging body of knowledge around what I would like to call data informatics. It is separated from data science. So as an informatician, what are the information properties of data? And what can we learn about those? And I know that can be, well, it's all metadata, but I'm trying to be anti-reductionist, so, and we'll go there. In 1967, a computer scientist named George Mealy, were there computer scientists in 67? Well, he was working with many people on devising the data structures and the rules about how data structures and programming languages actually work. And he wrote a paper called Another Look at Data, which begins with the sentence, "We do not, it seems, have a very clear and commonly agreed upon set of notions about data, either what they are, how they should be fed and cared for, or, in this context, or the relation to the design of programming language and operating systems." So I think the first half of that's still true, and I think the second half is how they're related to the practices and processes that we're actually trying to put in place to manage, take care of, keep around forever, throw away, look at data. So I'm hoping we can have that kind of discussion here. Kirk Borne will start, Peter Fox and John Chin will follow up, and please introduce yourself in any way it seems appropriate.
Introduce myself any way that seems appropriate. Okay, I'm Captain Kirk Borne. Matter of fact, I am a rocket scientist. I'm originally from Louisiana, but I only work in space. Okay, so you can catch that analogy. I am from Baton Rouge, actually. So it's very early Friday morning, and I need to be awoken a little bit here. I don't know about you, so I'm going to deviate a bit from the slides here, which are a little bit too formal anyways, and I'll probably go through them second. But first, I want to just tell a couple of stories. So what is an astronomer doing standing in front of you? And I had that question at the lunch table yesterday because I found myself with a bunch of wonderful science research librarians, and what am I sitting here for? And it was, of course, a good reason to be there. But I wanted to tell you a little bit of why that is. And a couple stories related to that, just to sort of start the morning storytelling. So someone mentioned we could sit around the campfire here, but Joe didn't start this one campfire. Anyway, so about a dozen years ago, in the middle of a period where I was working as a project manager on a contract at NASA for the Astrophysics Data Facility at the Goddard Space Flight Center in Greenville, Maryland. I basically just managing a bunch of scientific programmers and scientists who were providing data and data services to astronomers for a lot of the NASA astronomy missions. And one of the guys working with me was doing a lot of work on the class of stars called the OB stars, which are very hot stars, and they have all kinds of really interesting phenomena. They're shedding mass, and they're giving off all this plasma, and it shows up in all kinds of exotic behaviors in the atmospheres of these stars. And so he was studying a large data set from this ultraviolet Explorer satellite, which had been in space. And he was putting all these data together to discover interesting patterns in the data. And he used this term I hadn't heard before. So it's about a dozen years ago. He said he was doing some data mining. And I said, that sounds kind of interesting. What is data mining? And so we had a chat about that. And so one thing led to another. And I went to a conference and saw him at this conference. And he said, come with me. I need you to talk to a guy. So I talked to a guy. And the guy was working on some other big astronomy project. And this guy was working at the Lawrence Livermore lab. And it was an astronomy project. They're using public telescopes and all public data, nothing national security issues dealing with astronomy data. But they couldn't make their data publicly available because at Lawrence Livermore, things are behind a firewall, so they just couldn't put their data up on the internet and expose it to the other astronomers of the world in the same way most of us do, because they had all those restrictions at their place of employment. So they asked me if they could put this enormously, unbelievably huge data set on the National Space Science Data Center servers at Goddard, where I was working. And so this enormously huge, unbelievably large, unmanageable data set was 1 terabyte. And of course, 1 terabyte now costs you, like $80 or something at Walmart, right? So, but back then, 1 terabyte was ridiculous. And to show you how ridiculous it was, when I came back to work the next week after the conference and talked to the managers at the NSSDC, the National Space Science Data Center at NASA, and asked them if we could put this data up there and make it publicly available. Because this is NASA's role to make public all these space science data. They looked at me like I had 3 heads on when I asked this question. They said, "You do realize, of course, Kirk, that we've been collecting all data from all NASA missions since the beginning of NASA. We have 20,000 different instrument data sets here, whose sum total volume is about 1 terabyte. And you're asking us to add just one more to the 15,000 data sets we have, which is equal in size to all of those. It just isn't going to happen." So that very instant, I think, was the first notch in that click in my head of what data mining is useful for. And that is, the volume of data was so different from what people were used to that you just couldn't deal with it in a normal way, even though we could look back and laugh now, 1 terabyte, ha ha ha. But back then, it was sort of a ridiculous thing to be asking. And there had to be some new way, some new tool, some new algorithms, or something different in order to make that possible. And so given the impossibility of it, I went back to my colleague, the guy who was working with me, who was there, and we talked, and decided we'd put in a proposal to NASA for the independent researcher grant programs, and just independently get funding to buy this enormous data server and the web interface and data mining tools to go with it. And so I did a little bit of research in data mining tools, and we wrote this proposal and submitted it to NASA. And reviews came back, and if you're familiar with the old master ways, it was sort of like relevance to NASA, scientific merit, and a bunch of other things. There were like 4 categories, and the highest you can get in any of those categories is outstanding. Well, we had straight outstandings all the way through. And the summary review comments from the panel said this was the most creative, most innovative, most amazing proposal we have ever read. It absolutely must be funded. Well, you can guess the outcome. It was not funded, because it didn't fit with the program manager's plans. And so I learned a lesson there, which carries with me to this day. So some people say I'm a bit of a pessimist, and I first saw Peter this morning, so there's the pessimist. Because I think we still have a big hurdle to get over in science, on both ends of the spectrum. That is the practitioners and the new students, the future workforce, people recognizing the importance of this. And so, I'm going to keep in the vein of storytelling for a second here. I was still sort of not sure too much of what data mining was, even though I talked quite a bit about it in a wonderful proposal that wasn't fun. And so sometime in that following year, I don't remember exactly when, but there was this announcement, one of the usual daily science seminars at NASA. And there was a seminar from some person from IBM, and I'm sorry, I don't remember her name now, but she was giving a talk on data mining at the IBM Watson Research Center. And so I said, okay, I should go to this talk and see if I can learn something about data mining. So I went to this talk, and I was in a room with a whole bunch of computer science guys and gals, and not too many space and earth science types then, but I was probably one of the few in there. And so the first half of the talk was very mathematical. And this is fine, this is what it is. I mean, a lot of really interesting algorithms. but I just wasn't getting it. I mean, that's fine. I mean, it was what she was doing, but it didn't answer the question for me. Okay, what are you doing it for? What is it? What's the purpose? What's the application? And so halfway through her talk, she stopped in the middle of her very mathematical presentation and started talking about their summer internship program. And you could just hear a pin drop in the room. Everyone just sort of looked at each other like, well, that's a weird segue. I mean, from all that math to talking about your summer intern program. I mean, that's great, but I mean, they just, what's the connection here? Okay. And so she started talking about how in New York City, at the Watson Research Center, they invite these students from inner city and from Harlem and from these really hard parts of the city and teach them data mining. And I don't know about anybody else in the room, but I was like immediately skeptical. I said, right, you're taking inner city, hardened kid, right, and you're teaching them data mining. After what I just saw for the last 30 minutes, and you're teaching them data mining. And so she sensed the doubt and the incredulity in the room, and she sort of, I think, planned it that way. I mean, just to get our attention, which she did by that moment. And she proceeded to talk about the most important thing in the lives of these children, or students, I should say, high school students. What's the most important thing in their lives? I'm scratching my head, I don't know. I'm a Louisiana boy, what do I know about inner city New York? And she said the most important thing is street basketball. It's absolutely the thing. I mean, that's what they live for, is street basketball. You don't think it's school? No, it's street basketball. So then she went from that immediately to talking about this software package that they developed called Scout, which is now called Advanced Scout, which is a software package they developed for the NBA, National Basketball Association, to do data mining and all the play-by-play histories of all the games in the NBA. And the NBA actually keeps record of this in a database, so they actually, way ahead of their time, the NBA was annotating video. Okay, so they had videos of all their games, and they annotated it with a play-by-play. So who was doing what, whether it was a 3-on-1 or a 2-on-1, did the guy take the layup, take a jump shot, pass it off, whatever, and 3-on-1s, and I mean, all the different situations in basketball, and they were mining this to discover how to defend against their opponents and how to play against opponents. And every one of the teams in the NBA had this software and was using it to coach their teams. And so when they introduced this to those high school students, immediately they became convinced they needed to learn what this stuff is, because that's the most important thing in their life is basketball. And they immediately were captured into studying data mining, and they actually were very successful in teaching these students data mining in their summer intern program. Well, all this was amazing to me. I mean, I think other people were spilling the similar amazement. This is phenomenal. But what she said next really changed my life. I mean, ever since then, I don't think I've written a paper in an astronomy journal. She said that their metric of success was the graduation rate of their students that go through their internship. And she said for the typical student in the high schools from which those students came, the graduation rate is about 50%. That is, half the students drop out before they graduate. The students that go through their program had a 97% graduation rate. And I just was like, I got to find out what this is. I mean, this is ridiculous. Okay, so anyone who is like interested in education, science education, whatever, which I was and have been, that was just flooring to me. I mean, it's like, if this is something that can capture that amount of attention, passion, and devotion in kids who basically want to just go out in the street and play and not go to school, but put them back in this classroom, and they actually, most of these students did go on to college as well, not when they graduated. If there's something can do that to them, I needed to know more about it. So this was around the year 2000. I spent a better part of a year just learning as much as I could about data mining, but primarily what I was learning, and some of you heard this story at lunch yesterday, so I apologize. What I was mostly learning was there was a lot of places on the web where people had tutorials, conference papers, all kinds of stuff. And so I created my own little web resource guide for scientific data mining, which was posted on the NASA website. And it wasn't anything that I produced. It was all links to other people. Okay, so I was definitely a novice, didn't know really very much. You couldn't get ready to talk about any algorithm in any intelligent way, but I could tell you what it was good for and what kind of things you could do with it, even though I couldn't probably explain it at that time. And so I had this remarkably a detailed web resource guide because there was just so many cool things going on in the field. Links to conferences and all this stuff, like I said. And so I wouldn't consider myself an expert, but I mean, certainly not at all, but just this is what I was doing. So this was the year, this was like the year 2000 and 2001. And then 9/11 happened. September 2001. On one November afternoon, a couple months after 9/11, I get this phone call in my office while I'm sitting there at Goddard. And pick up the phone, and the person says on the other phone says, "Can you brief the president tomorrow morning on data mining?" And I said, "You mean the president?" And they said, "Yes, at the White House tomorrow morning. Can you brief the president on data mining?" I said, "Are you sure you got the right phone number?" And they said, "Well," and I said, "Well, how did you get this?" And they said, "Well, they went to the long story of the importance of connecting the dots, Homeland Security, which wasn't called that at the time, and doing the data mining to discover other possible terrorist activities before they happened, which of course is what people really should have done, would have done, could have done, and they want to do again, as they want to do prevent in the future. So data mining was the thing. So they asked around various people around the President's Advisory Council, and they said, well, people at NASA must be doing stuff with data mining. So they called NASA headquarters, and they said, well, our science center, one of our science centers, like Goddard Space Flight Center, or NASA Ames would probably have this experience, but Goddard is right down the street from Washington, so you should call there. So they called someone Goddard, and then the next thing you know, someone mentioned my name because I had this website. So suddenly I became an expert. Okay. Well, I didn't get first prize. I didn't get to go to the White House, and the reason was because I was a contract employee, not a federal civil servant, and federal advisory rules prevent that kind of advisory going on, which I understand. So I got second prize, which was to go to the Executive Office of the President and to brief the Homeland Security Transition Planning Office, which was really very cool. So I got that. But anyway, so those stories are just to tell you sort of how I sort of got into this, and each of those was to me sort of a life-changing thing. The first one, life-changing, and seeing how this could impact education. And once students, young people see this and see what they can do with it, it just turns them on to science, it turns them on to math, it turns them on to using computers. And a lot of times, I see now, even today, when I do go to student orientations at my university, the students coming in, and we have this table set up for computational and data sciences, and they just pass us by, and so there's the biology table is a mile long, right? And everyone wants to be pre-med, right? So I sort of wander over there and just sort of chat. And the conversation usually goes like this: I pick someone out of the line, and I'm talking with her, and I say, well, and her parents are standing there with her, paying very close attention to what she's saying, because parents learn a lot from their kids when they talk to other people, right? I have raised two kids, I know how this works. Okay, so I said, well, what are you interested in? She said, well, I want to do science, but I want to do something with computers. Oh, really? You ever thought about computational science or computational biology? And they say, no, what's that? So then we have this conversation. And so I'm experiencing this over and over and over again, that once the students see what they can do with computational science or data science, which is specifically our topic this morning, they start getting turned on because they said, well, I never knew I could do that. I never knew that this possibility existed. And I wanted to share one other story, which has nothing to do with data science, but it's the same kind of thing. And it was another inspirational moment for me, which is, again, I'm in the mode of storytelling. And let me just finish this other story, and then I'll just tell you a few things about my slide to say. Okay, so this other story is a different kind of story, but again, to me, it sort of sets the frame of why I think we need to really engage younger people in this and not wait for them to come to us. We've tried at our university to build, and if you build it, they will come, that kind of thing. It's not working. Okay, there's lots of reasons I can go into why it's not working, but it's because they're not attracted to something they don't know that it is attractive, right? I mean, it's not like, it's sort of like the black hole, right? That's a good astronomy analogy. People in the public who haven't had scientific training think the black hole will just suck you in, right? They say, what would happen if we had a black hole at the center of the solar system? It would just, suck planet Earth and everything. No, it will not. We'll just continue orbiting around it just like we do today. It's not going to do any sucking in. It's just another gravitating body.